Today in this lecture I'll be talking about universal shift register. Let's have a look at it. The universal shift register. So these are the characteristics of universal shift register. So let's look at it. So a register that is capable of shifting one's direction only is a unidirectional shift register. That can be right shift register or left shift register. If the shift register shifts in both direction, that is known as bidirectional shift register. And if the register has both shifts and parallel load capabilities, we call it as a universal shift register or USR. So today we'll be trying to design the universal shift register. Okay, let's move on to it now. So a 4-bit universal shift register. So this is the circuit. I'm going to explain it later, but let's look at the question first. So I want to design a 4-bit universal shift register that has this certain functionality. So it has four mode controls. You can see these are the four mode controls. So I want the four operations it can do. Like when I will give an input of 0 0, the register operation will be nothing, no change. So the current output will remain unchanged. And when I will give 0 1 as input to the mode control, the register will shift the data towards right. So it will act as a right shift register. And when I will give 1 0 as input, it will act as a left shift register. And when I will give 1 1 as input, it will load the data at its input. So the input will go towards the output. Okay, so this is the basic operations we will be trying to implement in a 4-bit universal shift register. So for a 4-bit universal shift register, what you need is, as it is a 4-bit, you can see that it's a 4-bit, so you'll be needing 4 D flip-flops. Okay, for D flip-flops you'll be needing these 4 D flip-flops, number one. Number two is, see that as you are designing a 4-bit shift register, you'll be needing 4 mux. You'll be needing 4 mux. Second one is the type of mux. The type of mux that you need will depend on the number of mode control. So you have 4 mode control, so we will be needing 4 to 1 mux. So 4 to 1 mux. Okay, so that is the thing you will be needing. So I'll be using a temporary slide. This slide I will use this slide to give you guys a better understanding. So the basic idea will be something like this, that I'll need 4 to 1 mux. So we know that 4 to 1 mux has like this sort of 4 different inputs, right, one output, and it will go directly towards the input of a D flip-flop. Okay, and there will be the output. Okay, and there are your select pins S1, S0, through which we can select our modes or the functionality of the circuit. So this is the thing we're going to do. So let's take a look at the actual circuit now. So this is the final product of the circuit. Now let me try to understand how it works. So see that for the first mode control, for 0 0, when I will be pressing 0 0, no change. So present output will be current output, right? So there will no change at the output. So see that when I will be pressing giving input 0 0 at this point, mode control, all the mux will receive this, right? So the value at this point, that value at this point, this point, and this point, and this point, it will move towards this point, this point, this point, this point, and then after clock age, it will go towards the output like A3, A2, A1, and A0. Okay, For the first one, that is, we need not change any data, so the present output will be the next output. So if we put 0 0, 0 will be activated. So what we can do, we can take the present output, that is a3, for this bit, a3. We can take this, and we have see that we have connected it with the 0 number pin. So what is happening is, when we are putting 0 0 at this point, this pin is activated, and the a3 from this path moves towards this path, and it goes to this path. And after a positive edge, this value of a3 moves towards this output, so the output doesn't change. So in this manner, I can achieve the certain desired functionality. So for 0 0, I have shown you the one case for one bit. Similar thing will be happening for a2, a1, and a0. You can see that I have just did nothing but just put this a0 towards this 0 pin, so that when it receives 0 0 at this point, this pin gets activated, and this a0 is taken to the output again, meaning no change at the output. So in this manner, we can achieve no change at the output. Okay, let's erase this thing now. Let's talk about the next functionality, that is 0 1. You can see this 0 1 is the next functionality. Let me clear this thing for you so you can easily understand. Next functionality is 0 1, this one right here. So I need to shift the data towards right. So there will be a shifting like this. Say for example, this is a3, this is a2, this is a1, and this is a0. So I want a right shift. I want the data to be shifting towards this direction. a3 will go to a2, previous a2 will get to a1, previous a1 will get to a0, and a0 will vanish. Okay, so for again, see that what's the value, what will be the current value of this a3. Then I'll be inserting a value for a3. Okay, so this is the thing we are going to do here for right shift 0 1. So now if I put a 0 1, something like this, so again this one number pins will get activated. Okay, so what I can do, I need to put this a3 towards a2, and a2 to a1, and a1 to a0. So how do I do it? It's very simple. I will just see that for this one, at this point I need this previous a3. Okay, so how do I do it? As I know that if I put a 0 1, my 1 is activated here. What I can do is, I can just take this a3 and just connect it to the port number 1. What will happen when, and I give this as input, this a3 will travel from this path and through to this one number port and towards this direction and go to a2. So it will jump from here to here. Similar things can be achieved via connecting the same ports for the next registers. So a2 will jump towards a1, and by connecting a1 to the port number 1 of the rightmost marks, the similar thing is attained. Okay, similar thing is attained. So something like this. So what will happen to this one? I know that a0, the current value or the previous value of a0 will commit suicide, right? Gone. But what will happen to the current value of a3? See that I'll be what will be the input at this point? I'll be inserting a new value. You can see that serial input for right shift. So this is the working methodology. So now you can easily understand how it will work. Let's erase this thing. Let's talk about the next problems or next functionalities and how we can achieve those. So you can easily understand, for right shift we will be having So let's see this, the functionality or mode controls. See that for right shift, uh, we move from left to right, right? For left shift, that is for mode control 10, what we'll be doing is we'll be moving from, so this won't be the case then, right? This won't be the case then, so let's erase these things. Now we'll be moving from A0 to A1. A1 will be moved towards A2. A2 will be towards A3, and A3 will commit suicide, right? So there won't be any data of previous A3. But what will happen, to the current value of A0, we'll insert a new value. Okay, we'll insert a new value. Okay, so that's the thing we're going to do. Let's talk about then 10, that is shift left. So it is moving towards the left direction from right to left. Just remember this. So let's go towards the previous slide. Let's design it. So it will go from here to in this direction, right? So what we can do, we'll be putting 10 here, so all the number 2 pins will get activated. Okay, so all the number 2 port or 2 pin will get activated. What I need to do is I need to put A0 to A1. What can I do? I can just simply do this. See that I need to pass this data will be passed towards this, right? So I need to just, there is a connection right here, right, for 10. So I need to connect this 2 port with A0, and I can just do this by connecting with, see that I have just done this, A0. So it's simple. So then A1 needs to travel to A2, right? A1 needs to travel to A2. So how can I achieve that? So I will take the present A1 value, see that present A1 value, and just connect it with the pin number 2, and I need to make A2 travel to A3. How can I do that? In similar manner, I need to take the previous value of A2 and make a connection with the leftmost mux port number 2. In this manner I can achieve this. But what will happen at this point, what will be the current value of A0? For that purpose, I'm going to do is I'm going to inject a new value at port number 2, that is known as serial input for shift left. So in this manner I can achieve the left shift or left shift register. So let's erase this thing. So now let's see the final mode, that is the parallel load. So if you see this one right here, if I give 1 as mode control input, the functionality that will happen is parallel load. So let's talk about parallel load. So for parallel load, what will be happening is we see that we have some inputs lying out at the bottom. So we'll be giving some input here, whatever it is, and these inputs will travel to the ends of the output. That means I3 will be travel to A3, I2 will be A2, and vice versa. You can easily understand. Now how can we do that? Just remember, we are giving 1 as input to the mode control. So all number 3 pin of the mask will be activated and travel to the output, right? Travel to the output. So in this point, what we need to do is just connect these inputs, right? We are just going to connect these inputs and just give an input at these points, right? Now see that we have just only, this is a very simplified connection. We just made a simple connection to the port number 3 with the inputs. So in this manner, see that what will happen if I give input of 0 at this point, what will happen is this 0 will be traveled to this point. After a clock pulse, this 0 will be traveled to this output. So this will be happening in a parallel method. See that there will be 4 bits of data at the input. These 4 bits of data will be traveled to the output 4 bits after only one clock pulse. So this is known as parallel load. All 4 bit data traveled parallelly towards the output. So that's that. Thank you.